Hi there, Mr. Muhammed is here. This is the Revise for Checkpoint book. The first unit is very easy. As you see, check your understanding 1.1. It's just about comparing two numbers. It's too obvious. For example, 0.235 is greater than 0.215. 9,000 something, of course, is less than 12,000 something. This one is more important. Multiplying by powers of 10. Whenever you multiply a number by 10, the number just gets one more zero. When you multiply by 100, the number gets two more zeros, 1220 with two more zeros. When we divide by 10, one zero will be removed, so this is the answer. When you multiply by 1000, the number gets three more zeros. When you divide by 1000, three zeros will be cancelled. So these tips are good for the non-calculator paper. Divide by 100, two zeros will be cancelled, and so on. Sometimes we have decimal numbers, so the same thing happens with decimal numbers, but this time you deal with numbers after point. You deal with decimal places, not adding or removing zeros. You're gonna release numbers from after point, or you send numbers after point in the division case. When we round to the nearest 10, we are watching the units. If the units is less than 5, the units place will be 0. If the unit is more than 5, the tens place gets one more zero. So here, round to the nearest 10, we are watching the units. The units is 2, it's small, so the units digit turns to 0. This one round to the nearest 100. To the nearest 100, since we have two zeros, we are watching the second digit, which is tens place. 6 is more than 5, so the answer is 4800. Round to the nearest 10, watching units, so it will be 90. Round to the nearest 10, it will be 260. Round to the nearest 100, it will be 300. Round to the nearest 10, it will be 6820 because the units is less than 5. Round this number to the nearest 100. So to the nearest 100, we are watching tens. So we have rounding on decimal numbers. We have rounding to the nearest decimal place, and we have rounding to the nearest significant figure. To the nearest decimal place is easier than significant figures. One decimal place is right here. So we are watching the second decimal place to see will this 5 become 6 or stays 5, the rest becomes 0. Since the question says round to the 1 or the first decimal place, then we have to check the second decimal place. Is this number greater than 5? Yes, so the answer will be 18.6. One decimal place means in the answer we should have only one decimal place. One decimal place here, we are checking this is the first decimal place. We check the 4. 4 is a small number, so the answer is 304.8. It can't be 0.9 because 4 is a small number, can't change the 8 by 9. Round to two decimal places is here, so we're gonna check. We always check with the number on the right side, always. 7 is a big number, so it will be 8.07. Round to the third decimal place. Third decimal place is right here, so we check with the fourth decimal place. 9 is big, so the answer is 28.222. This one became 2. The rest is homework. Do it yourself. Rounding to significant figures. Rounding to significant figures. A significant figure is the digit, the first non-zero digit when we start to look at the number from left to right. Two significant figures, since the first number is not zero, so this is the first significant for this number, and the 1 is the second significant. So we always check with the number on right. 4 is a small number, so 4 cannot make this one 2. The result is 3.1, and it has two significant figures, 1, 2. 4 significant figures, 1, 2, 3, 4. So this one is the fourth significant figure. The number on the right is small, so the 1 stays 1. It will not be 2. 156.1. 3 significant figures, 1, 2, 3 is right here. The number on right is 5, is a big number, so the answer is 166. Let's do this one, number 8. 2 significant figures. We don't count the 0 digits when they are in the beginning. So the first significant figure is right here, and the second significant is here. So this one is the second significant figure. Then the number on right is 6. 6 is a big number, so the answer is 0.0032. The most common mistake about such questions, students will just write 32. No, you have to write the decimal places with it. This 31, it's not a normal 31. It's the third number after point, and this one is the fourth decimal place. We have to copy the zeros and the decimal point with it. Question 9. 2 significant figures. This is 0, we don't count it. This is 0, we don't count it. So this is the first significant, and this is the second significant that the question wants, the 0. The number on right of the 0 is small, so the answer is 0.010, because the number on the right side of the 0 is 1, which is not a big number. And remember to do the others yourself. One significant figure here is this one, the first one, because it's non-zero, it's not 0, then it's the first significant. The number on right is 3, which is a small number, so if we round this number to 1 significant, it will be just 1. Estimation, you're going to round the numbers, then multiply them to make the multiplication process easier, or multiply the numbers, then round the final answer. Both cases are fine. The same thing is for division. If we round, question says round the numbers to 1 significant figure and hence make estimates of the answer to each of these. 1 significant figure, it will be 200. Let's do number 1. 1 significant figure, the first significant figure is the 2, so it will be 200 times 40. Then there are 3 zeros, copy 3 zeros. 2 times 4, 8. So the estimation for this multiplication problem is 8,000. To estimate this, it will be 50 times 20. 50 times 20, that gives 1,000. The same thing is right for the division. Unit 1 done. Now Unit 2. Adding and subtracting this integers. This one, both numbers are positive, so we're gonna add them. Here, one number is positive, the other one is negative, so we subtract them. 8 minus 1 is 7. Now look at the 8 and the 1. Which one is greater? The 8 is greater. The 8 is positive, so the 7, which is the answer, will have the same sign as the 8. Here, one is positive, one is negative. We subtract them. 6 minus 5 is 1. 5 and 6, which one is greater? 5 is greater, so the result has the same sign as the 6. 5 and 6, which one is greater? 6 is greater, so the result has the same sign as the 6. Sorry. Here, both numbers are negative. We're gonna add them. Both numbers are negative. We're gonna add them with the same sign. 3 plus 4 is 7. They both negative. The 7 is negative. One is positive, one is negative. We subtract. 6 minus 2 is 4. The 6 is greater, so the 4 will be negative. One is positive, one is negative. We subtract. 5 and 7. So we don't say 5 minus 7. We say 7 minus 5 is 2. 7 is greater than 5 if we ignore the signs, so the 2 will be negative as the 7. One is negative, one is positive. We subtract them. 1 minus 1, 0. And 0 doesn't have sign. It's not okay to say negative 0 or positive 0. This one, both numbers are positive, but there is a subtraction between them. When there is a subtraction between them, we consider like this number is positive, so with this subtraction, we consider it as a negative number. Now we subtract them. 6.8 minus 7.2. Then it will be 0.4. But this 0.4 should be negative or positive. The greater one is the 7.2 if we ignore the negative sign. Well, the 0.4 will be negative. This one will be 0. And the rest is homework. Some good questions about prime numbers. Look at these list of whole numbers, integers, okay. Then which of these numbers are divisible by 3? To check if a number is divisible by 3, when you add all the digits of the number, it should be divisible by 3. Like here, 1 plus 0 is 1. 1 is not divisible by 3. It means 10 is not divisible by 3. 1 plus 1 is 2. 2 is not divisible by 3. It means 11 is not divisible by 3. 1 plus 2 is 3. 3 is divisible by 3. So it means 12 is divisible by 3. 1 plus 3 is 4. 4 is not divisible by 3 means 13 is not divisible by 3. And so on for 14. 1 plus 5 is 6. 6 is divisible by 3. So it means 15 is divisible by 3. For these numbers, it's obvious, but I tell you this way because it works for all the numbers. Even when the number has 3 digits, 4 digits, 5 digits, it works. 1 plus 6 is 7. 7 is not divisible by 3. 1 plus 7 is 8. 8 is not divisible by 3. Which of these numbers are divisible by 5? Divisible by 5, any number is divisible by 5 when the last digit is 0 or 5. Like here, 10, because it has the last digit 0, it means it's divisible by 5. This is 10 and 15. Why 15? Because it has the last digit 5. Which numbers are prime? A prime number is a number which is not divisible by any other numbers. It's divisible only by 1 and itself. So we have here 11 is a prime number. Remember, prime numbers are not all the odd numbers. Some of the odd numbers are prime, and 2 is the only even prime number. 13 is prime. 15 is not prime because it's divisible by 3. 17 is prime. Find the largest number which is a factor of 35 and also factor of 65. This is called the highest common factor of two numbers. To find the highest common factor for two numbers, so let's list the factors of 35 and the factors of 65 here. We want to find the highest common factor. So this is HCF, highest common factor, for 35 and 65. So 35 is 1 times 35. So the 35 itself is a factor. 1 and 35 are factors of 35. 5 and 7 are factors of 35. Factors are the numbers that they make this one, the target, in multiplication. 1 times 35 is 35. So 1 and 35 are factors of 35. 5 times 7 is equal to 35. So 5 and 7 are factors of 35. So done. For 65, we have 1 and 65, because 1 times 65 is equal to 65. So 1 and 65 are factors of 65. 5 and 13 are also factors of 65. Now look at these numbers. Which number is repeated and the highest one? So 1 is repeated, but it's not the highest. 5 is repeated, and there is no any other number greater than 5 and repeated. Well, the highest common factor for 65 and 35 is just 5. Find the highest common factor of 18 and 30. So again, we're going to do the same steps, this time for 18 and 30. 18 could be formed by 1 times 18, could be formed by 2 times 9, or 3 times 6. 30 is 1 times 30, or 2 times 15, or 5 times 6. As you see, 1 is repeated, 2 is repeated, and 13 could be also formed by 3 times 10. 1 is repeated, 2 is repeated, 3 is repeated, but 6 is the largest repeated number in the factors of 18 and 30. So the highest common factor of 18 and 30 is 6. Here's a part of CV. Prime numbers. Prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are some prime numbers. Prime numbers are marked in bold and shaded. Non-prime numbers are grayed out. Use the CV to answer the following questions. Okay. Find the next prime above 31. So it's so obvious, 37. Write down all the prime numbers between 40 and 50. So the prime numbers between 40 and 50 are 41, 43, and 47. How many prime numbers are there between 1 and 20? So 1, 2, 3, 4, 5, 6, 7, 8 prime numbers are between 1 and 20. Is it true that 51, 61, and 71 are all prime? Well, 61 and 71 are prime, but 51 is not prime. 51 is divisible by 3. Multiplication and division of integers. Okay, that will be in the next lesson.